Hi guys, so I'm going to go through this Unit 8 practice test here for you. So I'm only going to go through question 13, which is the end of 8.1, 8.4 material, and I will post the second video soon. So, first question, which kind of energy is stored within a chemical substance? So we have to think, what is a chemical substance? Well, something like methane, CH4, which when we bond looks something like this. And so where the potential energy is stored is in the bond. So they haven't quite actually reacted yet, but they have the opportunity to react. So it's potential energy stored in the bonds. Number 2, the temperature of a sample is the measure of, this is a definition. So average kinetic energy of its particles is the definition for temperature. Temperature is a measure of the average kinetic energy. In a lab where the air temp is 22 degrees Celsius, a steel cylinder is at 100, submerged in a sample of water at 40. In the system, heat flows. So this is from where it's hot to where it's not. So in that case, the cylinder is hot and the air and water are not. So it'll flow from the cylinder to the water and air. Then when a substance is dissolved in water, the temp of the water increases. So this is described as exothermic. So if the temp of the water, we use the water to measure the energy change. If the temp increases, that's because our reaction produced energy that then goes into the water that raises the temperature. So C, exothermic. Given this reaction, what describes the reverse reaction? So this is the forward, if we were to go left to right. Now if we reverse it, we would get H2 plus half O2 makes H2O plus 286 kilojoules. Now, because this energy term is on the right-hand side, that means it's producing energy and exothermic, and it is now releasing 286 kilojoules into the surroundings. Number 6, what is the total number of joules of heat absorbed by 65 grams when the temperature of water is raised from 25 to 40? If we are talking about temperature raising, we know right away we are using Q equals mc delta T because we need a change in temp to measure. Change in temperature term. So we are putting in 65 for our mass. C is always our 4.18, and then delta T is 15 degrees. If you calculate that out, you get 4,076 as your answer. A 36 gram sample of water has an initial temp of 22. After the sample absorbs 1200, what's the final temp? Again, we're talking about a change in temperature, initial and final. So we are using Q is equal to mc delta T, except we're going to have to break apart that delta T term. First, we solve for delta T, which if you do, it is equal to Q is equal to mc. Put in our terms. Our energy term is 1200 joules divided by our mass of 36 grams times 4.18 joules per grams degrees Celsius. If you calculate that out, you will get 8 degrees. So if our initial temp is 22, you are going to be adding the change in temperature since it's absorbing. That gives you 30 degrees Celsius. A sample of water is cooled from 45 to 35. So again, change in temperature. We are still working with mc delta T. By the removal of 84 joules of heat, what's the mass of water? Well, mass is equal to Q over C delta T. That will be equal to 84 divided by 4.18 times 10, because that is our change in temperature. Calculate that out, you get 2 grams. Number 9. What occurs when a substance melts? So you have to think about endo and exo phase changes. Endothermic are the things that take energy to happen. That would be going from solid to liquid, liquid to gas. You could go, oh, that was not G. Solid to gas. These are endothermic. They take energy to happen. Exo are the opposite. So if we go from liquid to solid or freezing, if we go from gas to liquid, condensing, or gas to solid, deposition, these are going to be your exothermic. So if a substance melts, this is going from solid to liquid. So So this is going to be an absorption or an endothermic reaction. Number 10, what's the minimum amount of heat required to completely melt? So if you see melting, freezing, boiling, condensing, we are using either HF or HV. HF is heat of fusion. That is the melting, freezing phase change. HV is going to be the boiling, condensing phase change. So either of those. So we're using melting, so we use HF. Q is equal to HF times M. HF for water is 334 joules per gram. M is going to be 20 grams for this problem. Calculate that out. You get C. Number 11. In the heating curve shown below, heat is applied to a solid substance at a constant rate. So what accounts for the fact that this segment is so much larger than here? So we first have to break down what each of those segments mean. This segment is when we are going from solid to liquid. So this is the melting. And this segment is when we are going from liquid to gas or our boiling. So it's asking, why does it take a lot longer to boil something than melt something? Well, this has to do with the heat of vaporization being so much larger. So we just talked about the heat of fusion, which is 334 joules per grams. This is 2,260 joules per gram. So if we have the same amount of sample, think of if you're trying to push something up the hill, and for example, like a car. And so trying to push a car up with the e-brake off would take less energy than if you tried to push a car up with the e-brake on. That's kind of what's happening here, is that the amount of energy is different, even though it'd be the same vehicle. I don't know. That's my best attempt at an analogy. All right, 12. The strongest intermolecular forces of attraction exist in a liquid whose. So this is just thinking about what it means to have strong intermolecular forces. The stronger intermolecular forces, the less likely you are to break apart and volatilize, which has to do with vaporization. So, stronger the forces, less likely to turn into a vapor, so it's going to take more energy to break it apart. So here is just the most energy per gram of substance. 13. At atmosphere pressure of 25 grams of compound at its normal boiling point is converted to a gas by addition of this. What is the heat of vaporization? So, talks about heat of vaporization, so we know we are using this equation here. Solve for HV, we get Q over M. Then you are just putting 34,400 joules divided by 25 grams. Calculate that out, you get